Hello and welcome to this video where we'll come into Pydantic AI. This is a really good framework for creating AI applications. So you can use this for AI engineering. You can create RAGs, you can create chatbots, you can create AI agents in a very neat way since it has it's integrated with Pydantic. If you work with Pydantic, it's a top library for doing data validation. That is the strong point with Pydantic AI, that you can get output from an LLM in a structured way. Usually LLM produces output in terms of strings, and if you want to make it into a structured way, you need to parse it yourself, or you use other types of libraries to parse it. But then many of the other libraries also depend on Pydantic, but Pydantic AI is developed by Pydantic team itself. This is really good. I think it's the right now to-go library to use for creating chatbots and creating agents and creating RAG applications and other types of AI applications. This is a really good tool. We will use it together with, first we'll go into some exploration of how it works. It's also noteworthy that this is model agnostic. You can use whatever model you want, but we will use Gemini as it has a very good free tier. And then afterwards, we will start with doing some explorations to see how it works to create a simple chat application. Then we'll take this into creating a chat application and then also connect it with a front end. And the front end, you can choose Taipy, you can choose Streamlit, you can choose whatever front end framework you want. But if you want other frameworks that is not in Python, then probably you do need to make it into an API, for example, a fast API. However, I will make it simple and maybe I'll choose Streamlit in another video. I'm not sure yet. But this is the idea, and I'm not sure if I will divide this into several videos or not. We'll see how long this video gets. I'll start in the browser here. We'll search for Gemini API, and here you have Gemini Developer API. We go in there, and then here you can see Explore Models in Google AI Studio. Let's go into that one. Here you need to log in. I have logged in, but then you click on here, get your API key, and you follow along how to do that. Here you can see I've gotten this one. You can click here, look up, you create an API key. And then you bring this API key back to Visual Studio Code, and we'll see you in Visual Studio Code. Here I am in Visual Studio Code, and let's start with UVVNV and then source.venbin activate to activate my virtual environment. Now it's time to install some stuffs. I will need IPyKernel to work with Jupyter Notebook. I will need to have, let's see, what else do I need? I need to have Pydantic. Is it Pydantic AI like this, maybe? No, it's Pydantic AI like this. Yes, underscore. Okay, Pydantic AI. Let's see what else I do need. I need to have .env, uv pip install python-.env. Then I will need to have uv pip install pandas. Or do I need pandas? Maybe I don't need pandas for this actually. I'll take Taipy. I need Taipy to build my front end. This could be it. I think I'm satisfied here for now. And if I need something more, I will install it on the way. Start with a .env here. And in .env, I will create here a Gemini API key equals to my Gemini API key. I won't show this to you, but you should fill in your API key here. Now I will create a Jupyter Notebook chat. I'll call it chat test chat eda.ipynb. I call it EDA as exploratory data analysis, but it's basically explorations. Okay, chat with Pydantic AI. Okay, here let's change our Python environment to the Pydantic, the virtual environment, and change this to Python. Let's start very simple. From Pydantic AI, import agents. And then we will need from .env import load.env. Then we'll take load.env. Then when we do this, we'll load the .env here. We can do os.getEnv, and then you can write Gemini _API key. And we need to have OS, of course, so import OS. When you run this one, you can run it to just test out to see that it actually prints out your API key. I won't do that because I don't want to show it for you. Here, you should try this out. Type in try to run this to see that your API key is printed out. Okay, but I won't do that. I will create a chat agent. Chat agent equals to agent. Let's see here. You search for Gemini. And you can see here, Gemini 2.5 Flash, we'll pick that one. You will know that this one, it will take from the environment variable. When you do load.env, you will have the environment variable. It will look for the Gemini API key or the Gemini Google API key. And after this one, we'll create a system prompt. The system prompt that I will pick is, let's see, be a joking programming nerd. I will make a very simple one. I don't use much prompt engineering here. I'll just make it very simple. Always answer with a programming joke, no matter what the question is. Okay? That is it. We have a chat agent. Let's run this one. You can see it works now. Agent is a Google model. And you can see a little bit we'll see how to use this one. To use this one, we can do chat agent. We can say chat agent dot run. Hello. You can see it's a coroutine. What does this mean? It means that it's asynchronous. We need to await for the answer. Await, chat agent.run hello. Run this one. You can see here's the result. We can say result equals to this one. Result. Why did the programmer quit his job? Because he didn't get a raise. Oh, this is really funny. Okay, result. We can say dot output, and you can see this is the output. This is the string that was the output. We can also control how the output should be, but we will keep it very simple in this lecture. We won't do that. Let's see what else. Let's try another thing. We can do wait chat agent.run. Tell me how to choose an Azure region. Okay, say result equals to this one, and then result.output. Okay, see what it comes up with. Choosing an Azure region. Oh, that's like a really complex switch statement in a try-catch block where the default case usually just points to East US 2. Okay, this is quite funny, but let's now use this in an actual chat app. Result.output. Actually, I will print this one. And now I will say, what did I ask you first? Because we will want to see if it has a memory or not. What did I ask you first? My memory is like a REST API, delightfully stateless. What was the first GET request again? My session data just isn't persistent. Okay, it's saying that it's not persistent. Okay, we need to know how to get the messages. Result.all messages. We can see here are the different messages that we have. We see the first one is be a programming nerd. Always answer with a programming joke. This is the system prompt. And then you can see there's some date and timestamp on when that was. Here you can see what did I ask you first. This is the only user prompt that it sees. And then this is model response. This is what it responded with. Okay, you can see a little bit more details like Gemini 2.5 Flash, etc. Okay, it doesn't have the memory. It has all messages looks like this. How to get it to have memory? It's quite simple actually. We can copy this one. Let's change this text. What did I ask you first? Let's see. How many servers do Google have around the world? Google Cloud Platform have around the world. Let's let this be the first question. We can print out the results. Okay, how many servers has Google Platform? That's a bit like asking how many bits are in a byte. Okay, that is good to turn it into a joke. But now let's we have result.allMessages. Because I don't want the first message to be always. Okay, let's see. Yeah, here you can see user prompt. How many servers do Google Cloud Platform have around the world? This is our first question. And then you can see the answer here. Yes. Now let's try to see if it has a memory. What did I ask you first? What did I ask you first? Now let's have a memory. Message history equals to result.all messages. And let's see what it says. You asked me, how many servers do Google Cloud Platform have around the world? My memory is excellent, unlike the bug that keeps escaping into production. Then it comes into a question. Good, it has memory. I will just try again. What did I ask you? Or let's see. Okay, tell me more. See if it can refer back to this last question. You want more? That's like asking a full stack developer for just one more feature before deployment. But since you asked for more, okay, yes, it seems to work. Let's make this into a real application now. To do that, I'll have a chat.py, and from Pydantic AI, import AI.agent, import agent. Then from .env, import load.env, and we will have, that should be it. And then load.env, and then class jokebots. I'll create it into a class, def under init. I will pick self.chat agent equals to agent. Then here I will put in Gemini 2.5 Flash. Then I will I will just steal this one. I'll take the same here. Copy this one. Okay, chat agent is this agent, be a programming joke. Self.result equals to none. We start with none here, and then def chat. I think this is the only method I need for now. Self prompt is a string, and it should return back a dictionary. Okay, here message history equals to self.results.all messages if self.results. Else, okay, we don't need that actually, because this is let's say self.result.all messages. Yeah, if there is self.result, else it's none. Self.result is none by default, since we have created it as none. Then we will make this message history into none if we don't have self.result. Then self.results equals to self.chatAgent. Here I'll use runSync. It didn't work in Jupyter Notebook with runSync. Instead, you need to await, because there is already an event loop there. I won't go into async programming in this video, but just know that you do runSync here, because I need this to make it work with Taipy later on. Prompt message history equals to message history. And that is it. Return, I will make a dictionary here, user, prompt, and then bot, self.result.output. That should be it. Then let's try this out. If name equals the main, and then I'll run this, bot equals to jokebot, and results equals to bot.chat. Hello there. Okay, then we'll print the result. Actually, I don't need to print result.output, just the results. Okay, run this one. Yes, seems to work. Why did the programmer quit his job? Then I will also copy this one to see. Let's see, we do print like this and then \n also. What did I ask first? What did I ask you first? Okay, hello there. Oh, hello. Then what did I ask first? Oh, you initiated the main function of our conversation. It was a classic print hello there statement. Okay, it refers back to the first message. Good, it has memory. As simple as that, we have a chat application. And now we will, with this, we can build our front end. Okay, let's build our front end. I'll call it main.py, and here we'll use Taipy to build it. Import Taipy GUI from taipy.gui, import GUI from chat, import jokebots, and this is it. Bot equals to jokebot, and then we'll have user prompt equals to empty, and then messages equals to empty as well. Then chat history equals to empty list, and then users equals to human, comma, bots. That is what we need in the beginning. Then we'll have a tgb.page as page. We will do with tgb.part class name. I will call this chat, like chat window, for example. tgb.text. Let's see, chat with jokebot. Chat with jokebot, mode equals to md, markdown. Then this should be it. If done the name equals to done the main, then we'll do GUI. Page equals to page. Then we'll have, I won't have a CSS file for this one. Make it very simple. .run. And dark mode equals false. Use reloader equals true. Port equals to 8080. Host equals to 0000. Okay, yes, this should be it. Actually, we can have dark mode on. It doesn't matter. Okay, like this. Then I will run this one. Mode equals run. Now let's create our chatbot. We will need to use tgb.chat. This is very cool. tgb.chat. What you need to place in here is messages. Then you need to place in users equals to users. This you can find from the documentation in Taipy. Sender ID equals to users of 0. Then you have an on action equals to send message. This is a function that we will create. I'll create this send message. It takes in a state. It will take in a variable name, string, and it will take in a payload that is a dictionary. This is important. Then I'll take print and I'll show you what the payload is very important, what it looks like. If I restart this one, you can see that we have a chatting window now. If I say hey and run this one, you can see this is the payload that comes back. It's a dictionary. You will get action as send message, args, and it's by doing an enter. If I say something else and I click it, you can see it's a click event here, args, click, and then you have here in the end of the args, you see this is the message and this is by the human, right? So that means we can extract some things from the payload. We can take out the message, for example, is payload.get args, and we'll pick out the second one is the message. If I take out the message here, and you can see, let's see, user equals to payload.get args of 3. Then we can have like user comma message. You can see if I rerun this one, clear the terminal, and I'll say hey. I'll say hey and enter. You can see human and hey. Based on this one, now we can get the message from the chat and let's do something with it. Try results equals to bot.chat message. We want to put in the message here, and then we have bot message equals to result.get of bot. Remember that we get out a dictionary from this method. We have the bot message now. Then we just accept here. We can accept an exception as E, and then bot message equals to an F string here, bot error. We can put in our E. Okay, then we take messages dot append. What do we want to append? In the documentation, it says it needs to have 3 things. It needs to have the ID in a string, it needs to have the message, and it needs to know which user it is. Then we can take string of length of messages. It needs to append a tuple of this first, and then the bot message, and then users of 1. This is the human. Finally, state dot messages equals to messages, like this. And this should be it. Let me see. Hey, Svei. Okay. Ooh, there's a message here. And then the bot answers, hey there. Why was the JavaScript developer sad? Because he didn't, okay. What did I ask first? You asked the grand opening, blah, blah, blah. Hey, Svei. Okay, cool. It works, but it doesn't put in the user prompt. Let's fix that. Here, we should have messages because we give it to state.messages, which we use to display the messages in tgb.chat here. We need to put in a messages here equals to, or messages.append. It's basically the same as this one. I'll just copy this one actually. Then string length messages. Yes, here we have the message. This is the human message. Then uses is 0. Save this one, restart this one. Let me see. Okay, clear this one. Hey. We can see, hey, this is what the user have written. Why did the program quit this job? We can take the race. Okay. Explain that joke more. Yeah, explain that joke more. Why did the programmer starve? Because he couldn't get any bytes. Oh, that was funny actually. Okay, let's see. What did I ask first? Why did the programmer use a screwdriver? Because he wanted to bite into the code. Okay, it refers back to this question. Okay, I found a bug that looked like the memory, it didn't have any memory, even if it did have a memory. Let's try this out first. Hey there. Now it should give an answer. Okay, hi there, blah, blah, blah. What did I ask you first? Yes, it says about here, very special string value, which upon inspection is hey there. Tell me a math joke. Bot error unavailable. The model is overloaded. Please try again later. Okay, I may have used it a little bit too many times. What did I ask first? Maybe I sent too many requests. Oh, okay. Yeah, we needed to wait a little bit. But, that's classic. If I were performing a git log one line, blah, 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 you will see that, would be hey there. It remembers. Okay, what did I do? Well, in the chat here, we had before, the system prompt was, I wrote no matter what in the end. I removed that one, and now it's be a joking programming nerd. Always answer with a programming joke. The memory works well. Cool. Now you have a chatting application after we have done this work. We started with some EDA with Pydantic AI, and then afterwards we went on to doing this chat class and tried it out in the terminal. Then finally built a Taipy application front end based on this. Quite cool and quite a short amount of codes. We got a chatting window that we can chat with. Also, since it's a Taipy application, you always have the possibility to style the chatting windows to your liking. You could make it look more, for example, messenger chatting or some other cool chatting styles. Maybe I will cover that in the future, but for now this suffices, and you have learned the logic behind it and worked with both Pydantic AI and Taipy. I hope you learned a lot from this video, and see you in the next video. Bye!